In this video, I'm going to be describing direct variation and how to write and interpret direct variation equations. Direct variation is defined by the equation y equals kx, where k is some constant, meaning you could have y equals 3x, you could have y equals 10 over 2x, you could have y equals 11 over 20x. K is just some constant number. K is also called the constant of variation. You find k by dividing y divided by x. So in this case, y equals 3/2 x. This is a direct variation because you have some constant multiplied by x. So here are a few different examples. Identifying from a table. So if you had some constant x being multiplied to get you y, therefore, if you divided by, we just talked about k is represented by y over x. So if I divided 21 by 2, I would get 10.5. Here, if I divided 14 by 3, would I also get 10.5? 14 divided by 3, it gives you no. You actually get 4.67. And if I divided 7 divided by 6, it would give me 1.2. So therefore, no, this is not a direct variation. In this case, if you were to divide y divided by x, you would get 5 divided by 2, which is 2.5. Here, 12.5 divided by 5 would also get you 2.5. And 30 divided by 12 also would give you 2.5. So the answer to this would be yes, it is a direct variation. To determine from a point, well, we know that k is what represented, well, the equation is represented by y equals kx. Well, we know our x value, we know our y value. We just determined that k is represented by y divided by x. So we know that y is 12, we know that x is 4. 12 divided by 4 is 3. So therefore, our constant of variation is 3. We can also use proportions to find different values. Suppose that y varies directly with x. Now, we know that y equals kx, so k equals y divided by x. So we can go ahead and find k. Well, we know that when x is 27, y is negative 51. So we know that negative 51 divided by 27 actually gives us negative 3. Now, since we know that k is negative 3, we can write the equation y equals negative 3x because that is our direct variation equation. And now we can figure out the rest. Find x when y is negative 17. So therefore what we're going to do is we're going to plug negative 17 in for y. So we'll get negative 17 equals negative 3 times x. Divide both sides by negative 3, and so therefore x would be a positive 17/3. Now, there is actually a trick. Anytime you're dealing with direct variation, you're actually dealing with proportions. So if we were going to have an x value over a y value, or a y value over an x value, either one, it doesn't matter, then we also can have another y value over x value. So for example, if x is 27 when y is negative 51, then find x when y is negative 17. So if y is negative 51 when x is 27, then y is negative 17 when x is what we're not sure of. You can cross multiply, leaving you negative 51x equals 27 times 17, which is a negative 459. Divide both sides by negative 51, and they will reduce to 17/3. So you can actually create proportions from a direct variation. Real world connection. A dripping faucet wastes 1 cup of water if it drips for 3 minutes. So you could say for every 1 cup of water, it is going to drip for 3 minutes. Find the amount of water wasted. Oh, it varies directly with the amount of time. So find the constant of variation of an equation. So the constant of variation technically could be 1 over 3, or it could be 3 over 1, depending on what you feel the y and your x coordinates should be. How long must a faucet drip to waste 4.4 cups of water? Well, this is our proportion. So if we know that it's going to waste 4.4 cups of water, I'm going to put it in the numerator because my proportion had the cups in the numerator. We do not know how many minutes that will take. So we've now created a proportion. 1 cup of water times x, so 1x, is going to equal 3 times 4, which is 13.2. So therefore, x is going to equal 13.2 minutes. Now, you need to put the units of measurement in order, because it is a real world connection.